This about laboratory work. I don't sure about number, but this work about pressure integration, about airfoil equipped with flap. I prepared 18 files, yeah. For each student's there are a file and different angle of attack and different flap deflection. And we need to work with picture. From this picture, we need to collect these data points. We have a thin line, yeah. This line for theoretical computation, and we have experimental points from wind tunnel. So as our course related to wind tunnel, we use points from wind tunnel, and we need to get this data from graph, convert picture into numerical form, into array of numbers, put this data from picture into Excel, and after Excel we need to put this data into MATLAB. Last times I showed this integration with graph2digit software, but in this case we will use WebPlot digitizer. This software give us ability to work with slightly tilted image when operator of scanner put documents on scanner not ideally. There are small angle between axis of graph and sides of image. For example, if I scroll down and we look carefully at axis, in this point, axis coincide with edge of window, but in these points we have a small deviation, yeah, and this deviation we must include in our calculation. And software WebPlot digitizer do exactly that we need, and we have this software in your Telegram chat. So I like this software and load a first picture, so we will have an example in our recording. Maybe we need to wait a few minutes, and I'll need to close browser because lack of memory. We're waiting to start our application, and I'll free memory from other software what we don't need now. So application starting to loading. Yeah, we have a window. It's a great success. I think it will be work faster in your computers. So it continue loading and we still waiting. Oh, it's working now. So first we need to load our image for each student, different file. And now I use where we go. So maybe I need to find this folder. in this folder exactly at desktop. So I put name of folder and load first file from that. So file loaded. After we don't change nothing in this window, put elegant access. Yes. And firstly, we have to calibrate our access. So we have 4 points. 1, 2, 3, 4. And we need to click this point on graph in those parts where we exactly know coordinate. So let's start. Put and we could increase this here. Put point this here. First point. After put this end of axis is exactly unity, yeah. So I need to think about axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it's end of axis. This. After vertical axis, we put first point exactly at 0 and second point at -6. So we put our 4-point around picture to complete, and we need to put coordinates from these numbers. Yeah, for x1 we show 0, put 0. For x2 we have 1, put 1, so nothing changes. For vertical axis, y1 we should see 0, and for y2 we need to put -6. So take OK, and we could start obtain our data points. So first point, second point, each point, we click each point, put a red dot inside our so we have points for upper curve. After we to view data, and we have a lot of points. There are a lot of digits. We don't need so many. We change digits, maybe put 3 or 4, depend on your decision. And select the fixed. And as column separator, we use space. So take format and something change. After that, we could copy to clipboard, and we need to run Excel, for example. So we have this data in Excel, and we need to align between 2 columns. So text per columns, select this separator, add the additional flag space, and okay. So we have 2 arrays of data. In my computers, in my Russian Windows, there are problems with digital separator. In Russian system, they use comma, but in English system, they use point. Depending on your system, maybe we need to change all comma to points. So I use search and replace all. So after I put space, points, Excel, think about this data as about numbers. So, and I can plot a graph. So I have this data. As you remember, in aerodynamics, there are conventions. Axis for pressure coefficients inverted. So we need to put axis forward and put reverse order. So we reverse the picture and we have this data in Excel. So look at picture. Maybe we need to change position of last point because there are problem. We need these points shifted more left than we need. We need to shift it right. So put I 97. Okay. So I have vertical massive of data for first element, for first airfoil. I return to our software, close, clear data. I remove all these points and repeat this procedure for lower surface. ADD points and repeat. Maybe this. Oh, we have points, view data. Now these points formatted properly. We just copy all, go to Excel, and put additional array here. There are less points for lower surface. We replace comma to points and we could plot data for this. So ADD additional. So it's values for lower surface. Maybe we need to change order of these points. So there maybe need small fixes. You need pay attention to order of point along its axis, because in this case we have 004, 0172, and these points more left. So we need to change its coordinates for this point slightly. So maybe I put this and look at graph, these points slightly move. So I have a properly organized data. Maybe we need to ADD additional points in start. So 0.0. So ADD additional row and put 0, 0, and same for upper curve. So after that, I put ADD this point to graph. Yeah. And same for lower curve. So, and maybe same for last point, 1, 0, and 1, 0. So we close at this graph perfectly at endpoints. So we have data in Excel for first element of picture, but we have second one, and this one have different x coordinate. So we delete all data from previous, delete, and we need to return to axis part of image. Put this, take quick calibration and change, move these points. For movement, we just click points and type shift arrow. So these points moves accordingly. And points slightly up. So exactly. And these points. And these points. What we have end of axis here. So we put these points, they complete, have same window, but we need to pay attention. In this case, we do type different numbers. So end of axis 0.3 and vertical axis ends at -4. So these points don't change. So we eliminate access to off and we will start to get data from graph. Also we can change color. For example, maybe not red but blue points. So I'll start to collect data. First, second, third, 4, 5. When I misclick, I could move these points by adjust points. I click after points and slightly by arrow move in proper position. So it's end. For upper curve, I have points. I will type new data and it will be here. So our flap ended at 0.3 with 0 and start at 0, 0. So and change comma to points. Oh, and look at plot. We could drive additional plot. Here may be a small problem with these points. We just remove minus, so point fixed. All other points okay. And we change order for vertical. Yeah, it's for flap. And we need second array of data for lower surface of flap. Clear. And start to type points one by one. This. Okay, we have points. View data, copy, go to Excel and put here. And we put the GG to plot this data. Oh, we have all data in Excel and we now don't need a picture. We need to integrate this data in MATLAB to obtain normal force coefficients. Maybe now we need a small sketch because there are we need an understanding about coefficients. I use a board. So in this case, we have an airfoil. And we have a flap with some angle between them. So we have a corner of airfoil. Also, we have a chord for flap. And there are a deflection angle between these two lines. Yeah. And this angle stated at picture. So when we return to picture and look at the bottom part, we have 40-degree flaps and alpha 0. Maybe I need to prepare better resolution picture. So I do it after lecture. Now we need just know that our flap deflected at 40 degree in this case. So this 40 degree. All forces when what we obtain from integration of this graph directed exactly perpendicular to chord to local chord of airfoil and flap. So this angle perfectly square, and same for this. But we need to obtain a lift coefficients. These normal coefficients just stated Cn. And when we integrate this data in MATLAB, we obtain just two values for Cn. But we need to obtain Cl, lift coefficients, and how we could do it. Also, there are a flow direction, yeah? And this direction described by alpha angle. So we have second angle between chord of main airfoil and flow velocity vector alpha. This is airspeed vector. So, and when we talk about lift, we talk about vectors that perpendicular to this curve. And we need to find this vector. Also, we could obtain a drag coefficients from these values. So we need to transform our data to different coordinate systems. We need to do a rotation of coordinate system axis.
Sorry, teacher, I have a question.
Hello.
Teacher. Alpha it's equal 0, but then
When alpha and when alpha 0, you just need to account flap deflection angle. So when alpha 0, your lift coefficients coincide with normal forces coefficients. You ask about that, about case with alpha 0.
Yeah.
In each picture different alpha, and yeah, there are picture with 0, but there are a picture with 10, 12, 8. So we just talk a bit about general case with different alpha from chord line. So
Okay.
we need to perform a rotation of this axis, and to convert our vectors we obtain from integration, we obtain two vectors, normal forces, first for airfoil and second for flap. And after we need to rotate this vector, and we obtain something like this. This is lift part of, and this is drag part. And same for flap. This is lift for flap, and this is drag for flap. So we could use cosinus and sinus of angles, or we could use rotation matrix and do matrix multiplication. I think with cosinus and sinus it's slightly more simple. So it's CD coefficient and it's CL coefficient, and same for flap. CL and CD. So another point, this angle alpha and this angle exactly same. So when we talk about flap, we just ADD, flap deflection to alpha. So we have a formula. CL for main airfoil equal CN for main airfoil multiplied by cosinus of angle of attack. And CB for main airfoil same but sinus. And for flap, CL of flap maybe equal CN of flap. I maybe this designation equal CN multiply the cosinus plus delta. And same for drag, but with sinus. So we have this formula, and the total lift equal CL airfoil plus CL of flap. So our task now to obtain CN vector and convert our array of data into single vector. This we do in MATLAB with using of integration function traps. So now I'm going to start MATLAB. This software we don't need now. WebPlot designer, I close it. Go to screen sharing and MATLAB. Maybe we need to wait like 2 or 3 minutes for starting MATLAB. Depend on state of system. So there are another, not a problem, but slightly an issue for what we need to put attention. Different spacing and different count of points at upper and lower curve. So there are two solutions. First, we could integrate independently lower curve, upper curve, and ADD with that. Or we do respacing. We use spline interpolation and convert to same spacing. I think we could do both. So firstly, we need to put our data into MATLAB. For this, we need to create new variable. 10 minutes MATLAB need to start. We just copy this first column of data and put in MATLAB by typing the new variable. Control V. So we have a data in MATLAB in single variable, unnamed. We need to convert in two different variables. Remember, this is data for upper curve, upper surface of airfoil. So we could accordingly. First column is our X up for airfoil, upper surface of airfoil, and type a name of variable, unnamed, open brackets, put 2 points. These double points mean that we take all data from first column. comma, and 1. It means first column. So we get a variable x up a the same count of rows, yeah, 28, and single column. This our x up. And same for CP up airfoil. Same unnamed 2 point, comma 2, second column from this library. So we have two variables. We could delete unnamed, and we have two variables. After that, we create another new variable with same name unnamed, but clear one, and put here second column from Excel. Here, and repeat same operation but with different subscript. Lower surface and also airfoil and same unnamed third column. Unnamed, I put it 3M, but we need 2. So it works. And same for CP. And we have all data in this for airfoil, and we need to repeat this for flaps. Upper curve flaps here, and X up F. Now flaps F unnamed first column and CP up flap named second column, and same for lower set of data. Oh, we get this set of data and delete. We don't need to delete. We could also clear this variable. Delete row. We clear all and put new set of data. Here it's for lower surface. And repeat same commands. X, L, O, F, equal, named. X coordinated, same for pressure distribution. So we have all data in MATLAB now, in MATLAB variables. Delete and name it, we don't need it. We have these variables and we could plot it for control. Plot X up A, comma, CP up A. This is a data for plot, and after settings, we need, for example, blue line. We need a square markers, and we need a connection between markers. So it's an option for plot. And we have a plot. I don't know a command for inverse axis in MATLAB. There exist same, but I don't know it. So we need to put command hold on to additional name. Slightly edit this for lower surface and change color, for example, to red one. So this is our graph for airfoil. We create additional figure and repeat this data, this is input for flaps. And for lower surface of flaps, maybe change color for black, then okay. And we have to plot Just I don't know how to swap axis vertical in MATLAB. Maybe we need to Google this command. So we have data in MATLAB and we have run out time in our Zoom presentations. So I think we need stop at these points. I convert video, upload after, and after small pause, maybe 10 minutes, we go to integration and obtain lift coefficients from these graphs. Now we don't need Excel, we close Excel. Maybe you need to save these Excel files for lab protocol. Yeah, but in my case, I don't need it. So I close it. And after small pause, we continue in MATLAB. So see you after 10 minutes.